to my YouTube channel. And I am Lokumar HN, Department of IAC, Sri Venkateshwara College of Engineering. So I did a technical seminar in my 8th sem. So it's on topic brainstroke prediction using decision tree algorithms. And this decision tree algorithm is a machine learning algorithm. So in this video, I'm going to tell you about this decision tree algorithms and how it can use it to predict the brain strokes. And I did this technical seminar under the guidance of our assistant professor Malay Naveen sir. Now, without any delay, let's get into the actual content. Today, I am going to explain about introduction, related background, working, implementation, future enhancement, conclusion, references. These are the contents for the today's video. First, introduction. A stroke is a condition that occurs due to interruption or a reduction in the blood supply to the brain. Due to this, the neurons in the brain suffer hypoxia, which leads to cell injury or even death of the brain cells if not treated in time. This causes permanent or long-term injury and affects the person's life forever. Hence, early detection and prevention of stroke are essential as it is one of amongst of the top causes of mortality and morbidity worldwide. Decision tree methods have been developed as a useful tool for this, and machine learning models have shown promise in stroke prediction. Decision trees remain suitable for use in healthcare applications because they offer interpretability and can handle both categorical and numerical data. A dataset containing demographic figures, medical record, lifestyle features, and other uh, features are used by this machine learning model. And this stroke is further explained as a medical emergency caused by a blockage or rupture of blood vessels in the brain, leading to oxygen deprivation and subsequent damage to brain cells. Machine learning models are introduced as a powerful tool in healthcare, capable of analyzing large datasets to identify patterns and make predictions. Decision trees are highlighted for their simplicity, interpretability, and effective use in handling medical data. So this is the introduction for the decision trees as well as for machine learning models. Now let's see what is the background study for this brain stroke. The overall prevalence of stroke in the United States is 2.5%, with more than 7 million people aged to 20 and older having had a stroke. The situation has a negative impact on the health and quality of life of affected patients. In addition, it puts a burden on hospital care, resulting in a shortage of available beds. In 2014 and 2015, the economic cost of stroke in the United States was approximately $351.2 billion. The dataset used here is from Kaggle.com. This dataset contains 5,110 rows of data. It contains patient gender, age, hypertension level, heart disease conditions, marital status, job type, residence type, average glucose level, body mass index, and smoking status, and whether they had a stroke or not. According to India Today, stroke is the second most leading cause of deaths in India, and about 1,85,000 strokes are reported every year in India, with nearly one stroke for every 40 seconds. This could delve deeper into the socio-economic and demographic factor contributing to stroke prevalence, such as aging populations, lifestyle changes, and access to healthcare. In addition to this, a brief overview of stroke risk factors, including hypertension, diabetes, smoking, and obesity, could provide context for the dataset used. In further details on the dataset sources, data collection methods, and any processing steps applied, such as normalization or feature scaling, would enhance understanding. This is a related background for my technical seminar. Now let's see the working and implementation of this brainstroke detection, brainstroke prediction by using this decision tree algorithms. You can see here we have decision tree, and decision tree is like a tree structure. So these are the algorithms of supervised machine learning used for classification and regression. It is described as a hierarchical tree structure which consists of a root node, n number of branches, internal nodes, and leaf nodes. The decision tree, as shown in figure, follows a method where it uses a tree-like chart to make predictions. The dataset is split into different sets based on importance and a significant feature. At each tree node, decision trees can be easily understood and very versatile. So you can see here it's a tree-like structure, and it's having some subtrees, and again for that leaf nodes are there. Like that, it's a tree structure and it's very useful. In the name itself, it's there. It's a decision tree. And this is the proposed methodology what we have used here. We will be having data sets and the benchmark data set collect if platform is at Kaggle, where we can collect data sets from there, and once data collection is done, then we will process the data, and we will features extraction, and we will extract some features from this data sets after data processing. And once the feature extraction is done, then we are going to select the some features, and we will do scaling. After all this, we will do again data processing, and with this data processing can be done by this machine learning algorithm. That is, in this case, we are using decision tree algorithm. Based on the decision tree algorithm, data processing will done once again. After that, we will evaluate the model and the tuning and how the results, and we will then we will do all the evaluations in this step. After once it's done, then we will see if any changes need to if we need to make any changes in the data processing, and again we will do the data pre-processing. And once after this process is like until unless we get a very good model, we will do this on repeating stage. Once after a model evaluation is done, then we will deployment, and we will monitor the model. So this is the proposed methodology. So So that's what I have mentioned here. That is data collection, gather data sets with necessary features, ensuring completeness, and handle missing values, and standardize numerical features for consistency. And we will feature selection is identify influential features using correlation analysis or domain expertise. Consider dimensionally reduction for higher dimensional data. Model selection. Choose machine learning algorithm based on problem type and data set size. Decision trees are apt for healthcare due to interpretability and flexibility. In this case, we are using data decision trees, so there is no doubt in that, and we without any other plans, we will use this decision tree itself. Once the model is selected, then we will train that model by using data, splitting the data for training and validation to assess performance. Utilize optimization techniques like gradient descent for model parameter updates. Model evaluation. Assess model performance using metrics like accuracy and F1 score, and we will calculate and with test and validation to ensure robustness and generalizability. So this is a proposed methodology explanation in one slide. Now we can see the data overview data sets from Kaggle. This is it has 5,110 rows and 12 columns. Those 12 columns like ID, gender, age, hypertension, R disease, ever married, work type, residence type, glucose level, body mass index, smoking status, stroke. These are some. These are 12 columns. Stroke indicates stroke risk. That is, one is for possible risk, zero for no risk. Data processing, remove missing values and standardized data types, perform one hot encoding for non-numerical values. So this is one hot encoding is a method used to standardize the data sets to remove the missing values, and we will split this data sets into 80% as a training data sets and 20% for validation data sets. This is like in a subject called software testing, we will be having some test cases to test our model or our project. We will be having some final output to in order to check that final output, we will be having some test cases like that. Here also we will be having some test data as well as validation data. Initially, a decision tree algorithm with a depth of 9 branches is applied for moderate complexity. Grid search cross validation is utilized from the sklearn library to find the best parameters. You can see here the accuracy with the depth 9. So for test data, the result will be 93.75%, which means this is accuracy. So this is a probability. And for validation dataset, that is 91.44%. To simplify the model and reduce complexity, the depth of the tree is reduced to 4. Adjustments in the code are made according to using matplotlib library to visualize the decision trees. I think many people you know about Python. So Python here we will be having in Python this library called matplotlib. So by using this matplot library, we will reduce that depth 9 into 4. In an attempt to maximize accuracy, the depth of the decision tree is increased to 16. However, increasing depth may lead to overfitting, which can be mitigated using cross validation. So again, if you we also further we can go to 16 also. This accuracy table confirms that as model complexity increases, accuracy decreases. In this tables, you can see we have three tables. That is test data gives 93.697% accuracy for 16, depth 6 16. When it comes to depth 4, we have 95.65%. So we can conclude that the accuracy table confirms that as model complexity increases, accuracy decreases. By increasing the depth, the accuracy will decrease. If the complexity decreases, then the model accuracy also increases. So you can see the decision tree with the depth 4. This is the one small image of this decision tree with the depth 4. So results accuracy, the metric used to for validating our model is accuracy score. So the accuracy formula is true positive plus true negatives divided by true positive plus true negative plus fault positive plus fault and negatives. This equation represents the accuracy used to evaluate performance of the model. This is the formula we use to evaluate the accuracy, and you can see in this table that for depth 4 we have 95.6%, and for depth 9 we have 93.75%. For depth 16 we have 93.6%. It is for drain data. When it for validation data sets we have 93.4%, 91.4%, and 91%. uh Future enhancements. So this section is like a combined decision trees with the deep learning algorithms like CNNs or RNSs to leverage their complementary strengths, enhancing predictive accuracy, develop visualization techniques to enhance the interpretability of decision tree models, facilitating understanding and trust among healthcare professionals, optimize decision tree models for efficient deployment in clinical settings, ensuring timely predictions for early intervention, customize decision tree models to individual patient characteristics, enabling personalized stroke risk assessment and treatment strategies. Here, I want to tell you that by using different decision trees in a single as a single tree, we can develop a random forest algorithm, so where it has a very good accuracy than this decision tree algorithm. That's the future enhancement of this decision tree algorithm. And also the further enhancements could explore emerging trends in ML and healthcare, such as federated learning, transfer learning, or explainable AI, and how they could be applied to stroke prediction. Additionally, the potential ethical implications of using machine learning models in healthcare, such as data privacy, bias, and transparency, could be addressed. The text could discuss challenges specific to deploying ML models in clinical settings, such as regulatory requirements, interpretability with existing healthcare systems, and physician acceptance and trust. This is all about future enhancement of this brainstorm prediction using decision tree algorithms. Now, let's see conclusion. The conclusion could summarize that the decision trees offer a valuable and accessible model for stroke prediction in healthcare due to their ability to handle both categorical and numerical data along with their interpretability despite requiring extensive pre-processing. Decision trees provide a solution to managing outliers and missing values, streamlining the data preparation process for stroke prediction. Challenges such as imbalanced data sets are addressed through techniques like resampling and appropriate assessment metrics, ensuring the reliability of stroke prediction models. Combining decision trees with the deep learning algorithms like CNN and RNNs holds promise for further enhancing the decision precision of stroke prediction models in healthcare settings. By embracing diverse data sources and employing advanced modeling techniques, the aim is to reduce risk assessment, early detection, and individualized therapies, thus reducing this burden of individuals and healthcare systems. And also the key findings and implications of using decision tree models for stroke prediction, highlighting their potential impact and potential impact outcomes and reducing healthcare costs. It could also discuss limitations and areas for further research, such as the need for larger, more diverse datasets, longitudinal studies to assess model generalizability and validation in real-world clinical settings. Expanding on these aspects would provide a more detailed and comprehensive understanding of the use of decision tree methods and machine learning models for stroke prediction in healthcare. So this is a conclusion for my decision tree algorithms, and I hope you got an idea about what is this brain stroke. So what I have discussed till now is brain stroke. It will be caused due to when there is a disruption of blood flow to the brain. So when there is no proper blood flow to the brain, then it will result in the death of that brain cells. So it's simple for human body. When there is no proper blood, when there is no proper water and food for humans, then humans will die. Like that in brain also, brain cells will die when there is no proper blood flow to each and every cell. We know the brain is a very sensitive organ in our human body, and it needs proper blood flow to proper functionality of the brain. And so in order to have a less complications, in order to have a better health, we need to take care of our brain health, and we need to understand how this brain stroke can affect our lives. So that I try to tell you about brain stroke, and I explained you how this decision tree algorithms helps. So this can happen for many reasons, like if some people who are having diabetes, the people who are having bp, the people who have the habit of smoking, who are addicted to alcohol, and the stress levels also matters. For example, the people who are working in government job, they will be having some less stress levels rather than the people who are working in private sectors. Like that, the risk factors are huge. So according to the risk factors, to take care of your brain health, and be sure that you will be having a very good brain health. So that's all for today. I hope you enjoyed my video, and these are some references I have taken from online tell you all about to tell you about this brain stroke. And thank you for watching my video. If you really liked my video, please do like my video, and share it with your friends and family, because it's a very very important aspect of our life, that is brain. So let them also know about the brain stroke and how our decision trees can help us to predict the brain stroke. Thank you.